So good evening to everybody. I will just wait a few more minutes before we start the webinar. Just give everyone a chance to join. So you might just need to bear with me for a few minutes. So it's 6 p.m. Texas time. So we'll just we'll start, and hopefully anyone who's joining late, we won't be gotten too far ahead. So just like to welcome everyone to this presentation. I would like to thank Jim for allowing me to present to the North Texas WebSphere users group. Now, the aim of this presentation is going to be to talk about code quality and what SonarCube can help us do to improve the quality of our code, with the end goal being that the better our code is, the fewer defects we have, the better the code performs, the easier the code is to maintain, and the overall cheaper the code is for the business. So when I mean cheaper, I don't mean this tool is going to allow us to outsource to some companies going to provide developers at $1 an hour. This tool is aimed to help us write the best code that we can, and to try to enforce our coding standards as our projects progress, so that we always have good quality code all the way through our project. We don't wait till the end to decide to do code reviews and improve the quality. So just so we're all talking about the same thing, and just as a bit of background to how the tool works and some of the terminology we're going to use, I was just going to go through some of the terms that we will be covering, and just to make sure everyone's on the same page. So the first one we're going to talk about is something called find bugs. So find bugs is a Java product, and essentially its job is to statically analyze your Java code. And it looks for things like unused variables, null pointer references, and non-instantiated variables, if-it loops, negative if conditions, things like that. So just there's a whole range of combination of coding issues and documentation. And coding standards and potential bugs that are fine. So hence the term find bugs. So it looks at your code and looks at various sorts of runs various sorts of checks. The next term is another Java product called checkstyle. And checkstyle is a Java product that its goal is to look at your code and look at it not from the point of view of what the code does, but from the point of view of how the code is written. So it has rules around, for example, the number of nested if statements, or the rules around the length of a file, or the length of the name of a variable. Make sure your variables are the right case. Make sure your loop variables are named correctly, things like that. It also enforces things like line lengths. The next one we're looking at is something called PMD, which is a combination of find bugs, but what it has over find bugs is something called CPD, or copy paste detection. So what CPD, or copy paste detection, is it's a tool that analyzes your code and looks for code which is similar or the same across your project. So with the aim being to prevent or detect where people have copied code from one piece of functionality and pasted into another piece of functionality, with the intent being that those sorts of pure copy paste code blocks are hard to maintain. They require additional testing because you now have to test the same logic from potentially two different paths. They're hard to when a bug is found, then there's multiple places that the code has to be fixed, and then the last issue is that when the code has to be enhanced, there's multiple places where the code has to be enhanced. So the more places you have to touch the code to make an enhancement or change a feature of the code, the more difficult it is, and the more potential there is for you to miss one and to get introduce a bug. This one here is technical debt. So technical debt is a term that describes how you measure the difference between the code quality you ideally have and the code quality that you have, and the difference being what we call technical debt. So it's debt that teams and developers have to pay off every time they make a change. So the lower your technical debt, also the lower the issues are with the code, so the higher the quality code is when you start a project, the easier it is for you to enhance and maintain that code going forward. So the easier it is for you to enhance the code, the easier it is for you to make changes, the easier it is for you to test those changes and deploy those to users. So you get more business benefit. When technical debt increases, i.e. people are less concerned about code quality, it makes it more and more difficult to improve the product, because you get more and more issues with writing code. So there's more rework you have to do, potentially more bugs, more retesting. So by keeping our technical debt low, it allows us to, using an agile term, improve our velocity. So each iteration or each deliverable, hopefully we can plan better and takes this the minimum amount of time. Continuous integration. Continuous integration is a process where all your code from your developers are integrated together in the source code, or from the source code repository into one place, and then they take that code, you deploy it, run your test cases, compile it, run your test cases, deploy it into an environment, and do your testing. So what it's aiming to do is to make sure that you aren't working in silos. So when people change code that affects other parts of the system or other components, we want to get that code into the continuous integration environment quickly, so that all the issues can be resolved. You don't want to be writing. So this is essentially to avoid the issue where you've got 3 or 4 different teams working on a deliverable, all think they're talking about the same thing, but they've all written their code and they've tested it. When they actually integrate the different components together, as part of the say user testing or acceptance testing, they don't work, because they've got slightly different assumptions, or they've got slightly different parameters, or slightly different contracts, or they've got code's got slightly different, or people developing the code had slightly different understandings to the requirements. So trying to get teams to integrate as often as possible to find those points of contention, points of issue. We'll just wait there just to see if anyone does have any questions. Okay, we'll keep moving on. Now, the continuous integration and all these discussions, or that discussion that we just had around code quality, that's aiming for what we call continuous delivery or continuous deployment, which are very similar terms. So continuous delivery is the ability for organizations to make changes to their code, allows them to integrate them, as in continuous integration of the code with the rest of the code, allows them to automate the deployment into it, say, for example, a test environment, to hopefully, ideally, automate the regression testing of that deployment, and then prepare that deployment for releasing to a customer. Now, no, that's not saying every particular change should go to a customer. What that's saying is there's potential for every change to be of a high enough quality to be able to go to a customer. So what this means is that we allows us to have smaller incremental releases that are ideally of higher quality and fewer defects, and the business see the benefits of the products that we're developing more often. Now, the last article is around, there's some principles of continuous delivery, and the interesting point here is, and this is where the SonarQube plugin that we've developed comes into it, and this is where SonarQube comes into it, and we're talking about build quality. So building quality into the release process. So after you've in your continuous delivery or continuous deployment pipeline, after your developers check your code in, the unit tests have run, it's been deployed to environment. Excuse me. We can look at the code quality and then decide that A, is the code or the deliverable good enough to go to the customer because it does its functionality, because it's been tested, and B, is it going to be good enough to go to the customer because the code is of a high enough quality. And we have, by delivering code of a high quality, ideally, or generally speaking, we can have fewer defects coming out of that code because we've taken the time and we've taken the energy to make sure it's the best written code we can within whatever restrictions we have. And so this is where the plugin and SonarQube comes involved. So what we're trying to do with the SonarQube product is we've built a product which has the same functionality as, say, find bugs, check style, and PMD, but we're trying to do it for message broker developers. So message broker developers have the automatic tooling and the SonarQube environment, or the environment and ecosystem, to be able to automate as much of the quality process and developing good code as possible to produce better code for our customers. Now, the last two terms, or the last term I'm going to cover here, is something called snowflake setups. And the only reason I'm covering this is not particularly related to there generally doesn't need to be something that you consider when you talk about continuous delivery. But what it means is every delivery or every artifact you produce is consistent. So what we're saying is, when we have a server and we deploy software to it, we want to have an environment which is about as similar as any other server that we've used to get to our production environment. So if we have a server in production that is different, vastly different to our acceptance servers and vastly different to our development servers, we're more than likely going to get issues because things are going to behave differently. So this is something that we're raising here because part of some of the checks in our tool does is to make sure that we don't have snowflake deliverable deployments that work in one environment when the server is the same, but work differently in another environment when the server is the same because of some missing configuration. So I raise this because we are looking at improving the quality of our configuration. Excuse me. So what we'll do is we'll jump into SonarQube, show you what SonarQube looks like and what it looks like for message broker developers, and we'll do a quick demonstration. So the quick demonstration essentially is we have Sonar running here. And you might have slightly different configurations. In this case, it's just running from DOSBox. And then we just run our analysis. So analysis can be run from our build server, for example, as part of our continuous build process, which we'll show you a bit later if we can get it working. But generally, it's the same analysis here you can run from your desktop. So what we have here is it's just going through. This is the third example of what we've done here is we've checked our code, we've run our analysis. When the analysis finishes, and it says it's successful, we'll go into our Sonar queue environment, and we can see there that, and this is going to be Canberra time because I'm in Canberra, but we can see there that our last analysis was very recent, and we can then look at the output of our analysis to see about the quality of our code. So there's 3 or 4 sections here that I want to discuss. There's something called metrics, something called duplications, and then there's the issues and violations. So the metrics are general information about your software that may or may not help you improve the quality by reporting it. So, for example, metrics like the number of files and the number of lines of code really aren't helping us to improve the quality of our code. They're just general information that gives us an idea of how big our project is, along with some other message broker specific metrics. So here we've got collected some metrics, the number of nodes, the number of input nodes, the number of HTTP input nodes, the number of SOAP input nodes, the number of SOAP request nodes. This is just some general things that people have wanted to keep track of. So when they start getting more, they just want to see, just have an understanding of where they're coming into their product from. Now this one here of the RCD nodes is a little bit more interesting because this is just a count of the number of RCD nodes or reset content descriptor nodes are used throughout the project. And now these are things that developers and architects like to keep an eye on because they are quite resource intensive. So having multiple ones of them could indicate that it's doing a lot of work, and it's just gives by having them highlighted here on the dashboard as an individual metric, it allows people to use the Sonar dashboard to dig in and work out where they're coming from and what they use from in the code. So for example, here we can see that these particular metrics are from something called, or 2 particular ones are called for something called flow4. So we can see here it's got 2 So we can see here it's got 2 RCD nodes. So from there we might decide to have a dig into flow4 from our toolkit. I'll just open up flow4. Okay, so what we've done is we've gone from a Sonar metric, saying that in this particular file there's a number of RCD nodes, to going into our source code and going to our toolkit, and we can see that we've actually got 2 RCD nodes in the same process, which seems a bit unusual. So that gives our developers a chance to go back in and have a look at code and decide whether they need to refactor the node to help improve performance. So that's the metrics. That's the basic metrics there. The other interesting metric here is the flow length. So what the flow length is it's the number of possible nodes that will run through in a flow. So a flow may have, for example, this one here will have a flow length of 1, 2, 3, 4, 5, 6 nodes. It has there's 6 nodes in the path. So in the case here, what this is saying us in the backlog 6 long flows, at runtime there's a possibility that it will go through 10 nodes to get to the output, or 10 nodes before producing an output, which may or may not be an issue depending on how often our backlog long flows is used. So if we look here and our backlog 6 long flows, we can see here that the path is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the longest path through our code. Now, if that's one of our irregular permutations through the code, we might decide that's not an issue, and that's fine because it may be some unusual circumstance, or it might be something to do with error capturing or exception handling, which doesn't happen very often. And so we're not too concerned about performance. But if for example, this was the most common path through the code, we might decide that we might need to refactor this and might need to structure it slightly differently to improve performance or improve its readability. So these metrics here that we're talking about here, they're not hard and fast rules, but they're giving us an idea of if we do want to change our code. Or give us an idea of where we might want to look at its our complexity and our performance. Next one here we're talking about is cyclometric complexity of the ESQL. So cyclometric complexity is a measurement of the number of executable paths through a code. So it's trying to give us an idea of how complicated the code is. So if we look here in our airline ESQL file, what this is saying is that within this file, and this is file-based, not function-based, so it can be a bit misleading. But within this file, there are paths through this ESQL. There are 37 possible combination of paths through the ESQL. So, example, we look here, and we've got this one path here. So we've got so this here counts as one because it's a loop. So there could be code that goes through this particular function and calls the loop or has the loops invoked, or there could be code that skips over it. So that's two possible paths through the code. In the case here, with this particular update function here, we're looking at, we've got a loop which counts as one path, and an if condition which is a second path, which and a nested if condition which adds two more additional paths. So here we're looking through 5 different paths through the code. Then we're looking at another 6, 7, 8 paths through the code. So this here is there's a number of different paths through the code that we really need to test, or permutations that we really need to test. So this is indicating this particular function is quite complicated in comparison to our other functions. So again, it's not a hard and fast rule, but it gives us an idea of where we can be looking at our code to decide whether or not we need to refactor it, or whether or not it's understandable. The last two metrics are message broker specific again, which is the string manipulation load and the weighted string manipulation load. So the string manipulation load is just counting the number of string functions within a function, just to give us an idea of how much string manipulation work, which can be quite CPU intensive, each piece of our code or each ESQL module is doing. So the ones with more, we might decide that we want to look at. Now, the weighted string manipulation load is a similar concept as the string manipulation load, but it's trying to take into account not just the fact that there's string manipulation there, but also the cases where it might be, say, within a nested loop, in which case, even though the function is only listed in the code once, it may actually be called multiple times. So in the case of a weighted string manipulation load of 4, maybe doing a lot more work than a string manipulation load of 10. So if you have one function that goes through the code, has no exit, has no loops, and just goes through the code and does a bit of string work, but does cause 10 string functions, so be it. But if you have another piece of code that has 3 nested loops that may go through the code thousands of times, that's going to be a lot more of an impact on your performance. So if we dive into the metric, we can see that the functions we're looking at, for example, flow1 compare, has a number of string functions being called. So for example, let me see if we can find some. Let me see. So we've got a lowercase, we've got a cast, lowercase, and I'm guessing there's a few others in there. I just can't seem to locate them right at the moment. The weighted string manipulation load is trying to tell us that within this particular function, there's some string work we're doing within a loop. So if we just look through here, through this code here, so in this case here, we're doing 2 trims, which is fine, but they're within a loop. So we might decide that's not going to be a performance issue, or it can't be a performance issue. Well, we might look at that and decide that that could potentially be a performance issue. We might decide to do things slightly differently if that's a concern. As I said, it's not a hard and fast rule, but just gives us an idea if there is some code we want to change. Is there any questions on that? Right, we'll just keep going. So that's covering off the metrics. The next one is the duplications, which is important, just for making our code more maintainable. So with ESQL, the SQL that the toolkit gives us to start with, there is a certain amount of automatic duplication. For example, the copy message headers, the copy message headers, and the copy and type message are considered by PMD when it runs through to be duplicates. So you just need to have a little bit of take this with a pinch of salt. So not all of these will be duplicates, but then some of them will be. So for example, if we look at this one here with 83 lines of duplication, we can see a fairly big function here. And then if we look at this, we can see that this other function here has the same amount of duplication. So we can see here that those 83 lines are duplicated in both functions, which suggests that there may be some common code that we could extract out, or some common business logic that maybe we need to process in a consistent way. But at least what we can do is maybe factor this code out into a common method or common function, and that way we've only got the code in one place to maintain. And we've only got one place in the code to test. And the last one, we just look at this. It's got 69 lines of duplication. So yeah, this is a bit of a false positive. It's just saying it's got a copy and time message, copy and time message, copy and time message. So that's duplications. Now violations. Now violations is what most people are more interested in. So I spent a bit of time talking about this. Violations are generally things that are either against our coding standards, or where the plugin has identified that our code is contrary to our coding standards, or where it's identified that code potentially could be badly performing, could be rewritten better, could be more rewritten and be more understanding, or potentially there could be a bug or a logic error. So at the moment, the product's got about 165 different rules that it checks against the code against. Now, some of them, there's a different range of different checks it's doing, from performance to code style. So what it's trying to do is mimic what we just said before with the find bugs, the check style, and the PMD. So some of the rules are simply about the documentation within the code. Some of them are relating to the line length and the length of functions, procedures. And that's like your check style sort of checks. Then you've got the find bug sort of checks. So whether or not a variable is being used, whether or not you've got some dead code because a method's not being, a function's not being called. Where you may potentially have a subflow which isn't actually used anywhere, so it's essentially dead code. And then also getting to the PMD side of things, where you've got things like where you may have atomic functions calling other atomic functions, and there's always a potential that you might have a deadlock situation occur. So it's trying to do that thread checking that you would get with PMD in Java. It's trying to simulate those same checks by looking at where all your atomics and your interaction between methods that have atomic entry conditions, to try to detect whether or not there could be a potential deadlock. There's a couple other checks that are worth mentioning. which we can go into the files to have a look at. Now, there's checks relating to the SQL. So what we do is we extract the SQL and we look at the SQL. So as part of your configuration of setting up your product, part of your configuration of setting up SonarCube to run against your product, there's a number of settings in the properties file that you can configure. So in this case, the ones we're interested in here, the one we're interested in here is something called the Sonar MDB driver. So what this is saying is that when you are using SQL from Message Broker, we're going to try to work out what your SQL is doing to the database and try to give you some feedback on whether or not we think it's best practice. So when we say best practice, it might be, for example, are you using a select star over named columns? Now this can be an issue because if someone does add a column later on that has slightly more data than you're expecting, or increases the size of the data and you don't need it, that's a potential performance issue because your SQL is going to be reading in a whole bunch of data that your code doesn't actually need to have. So you might have code that works fine, and then suddenly you start getting a performance issue because you're using a select star and someone's added an additional field to the column, or an additional column to the table, and that column's causing a lot more data to be brought down, a lot more data to be loaded into the execution environment when it runs. And relating to that select star, there's also some checks to see whether or not you're doing a select star without any where conditions, for example. So if you're just doing a select star on an indiscriminate table, then there's potentially going to be performance issues if that table gets quite large. So we're just giving you a warning because a lot of test environments or development environments may actually only have a limited set of data that people are testing with. So the performance issues don't become apparent until your number of people in your select statement goes from 100 that you've been using in your test case to 50,000 that you have seen in a production environment. So I was just trying to give you that early feedback that the code might need to be looked at again because there might be performance issues when it runs in production. We also look at the talking about database checks. We also look at the usage of tables and columns and indexes. So if you've got an SQL or SQL code that's let's try and pick one. Let's see if we can find one. So if you've got an SQL code that is looking at a table or is selecting from a table that the plugin cannot find, it gives you a warning to say that you might actually be selecting from a table that's not valid. Now, most of these things would normally get checked as part of a testing process where you deploy the code, you run it, it tries to connect to a table that doesn't exist, and then it will explode, and you'll go, okay, there's an issue. This is valuable because if you have a lot of permutations in your code, you might have more paths. You might have paths that are very difficult to test. So by having an automatic check on the tables and columns used in the more difficult scenarios, helps find those issues earlier before they go to test or before they go to some sort of regression testing where they might be doing some of those edge cases. And then we talked about that's columns, and we also need to talk about indexes. So when we analyze the SQL that's actually being run by the broker against the database, we're also looking at the indexes that the code's using. So if there's a table with an index, or if we're doing a select statement on a table that doesn't have an index or an index that we're not using, we'd like to warn the user if we think that's going to be a performance issue. So ideally, we want our select statements to be using indexed columns where possible. So it just gives you some feedback that an index is not being used, and potentially an index does exist, and maybe the SQL needs to be structured to make use of it. So that's the general checks that we have. Also the general groupings of checks, and we'll just dig into a few of them just to give people a bit of an idea. I'll just take a break for a second, just see if there are any questions. Right, we'll keep going. So this is just a summary of the issues that have been found. So what we can just do is go through a few of them just to show you how it would look. So this one here, no broker schema is defined. So this is more of a code documentation or code structure sort of issue. So in a large organization, you probably want your code to be organized in a reasonable way to make it A, more manageable, and B, easier for people to find things logically. So if you have a particular packaging or schema naming structure, you probably want to make sure it's obvious for people where things are, or try and help people find things, so don't spend time looking around code trying to find things when the name of the schema might help improve that cognitive understanding. So what we're saying here is that there's no broker schema. So you've got an ESQL function, and we'll just jump into this function here. So we've got an ESQL function. Well, we've got an ESQL file that's got a number of violations. One is there's no broker schema. So we haven't defined it to a default schema. We haven't set it to a schema, so it's ended up in the default schema. The next one here is for people that make heavy use of, say, SVN or Git, where we want to encourage developers to put the author version and date in all the files that they check in, so that SVN or Git has the ability to update those annotations within the files with the last person that changed the file and the date and the version that was changed. And that could be either because SVN wants to do it, or you might have some sort of build process that marks it to say this particular file was last changed in this particular version of the release. The next two are this one here is where you might want to have a standard header or comment block in each file, and that would be something you can configure from the building property, the Sonar build properties. So there's two things here. One is you want all your you're saying that all your schemas for SQL, you want to be in a particular package, or in particular namespace. In this case, I want all my schemas to be in AU test company. So if your company name's IBM, it might be you want everything to be in IBM.integrations.messagebroker.project X, for example. So that just makes sure you try to enforce the standard of where people are actually putting the files. The other one here is as I said, is the header. So this is enforcing that there's some sort of company header in all the files. So this might be some licensing agreement, or maybe it's just as simple as the name of the company. Oops. So we're saying this file has a whole bunch of violations. Now, this particular violation here is where we're mentioning Snowflake servers. So what this violation is saying is that the plugin has found that you're using an Ant deployment script, but the Ant deployment script doesn't include a reference to this particular flow. So this could either mean that the flow is never supposed to be deployed, or it's only maybe for testing. The flow's been deleted, or the flow is no longer used but hasn't been deleted from version control, so it's dead code that probably should be cleaned up. Or it could indicate that the developer hasn't included in the deployment script, which means it gives you there's a potential for the flow to exist in other environments up to, say, production, when only the Ant build script will actually run. So this is this is trying to warn you when you may have developers adding flows or manually deploying builds into different environments for testing, but you've never had them add it to the automated tooling or the automatic scripting, so that you might potentially end up with a different version of your software going into, basically a unique Snowflake version of your software going into an environment, because you don't have all your artifacts listed and referenced. And then we also do that with MQ configuration. So we look at your MQ configuration files and determine whether or not all your queues have been named according to an appropriate naming standard, or your alias is named according to whatever standard you might have. That the names are compliant and won't have the queue names aren't assigned in such a way that they may work in one particular environment, so they may work in Windows, but they may actually not work in the production environment, which may be, say, running Unix or some other operating system. It also helps logically with logical errors, because we can look at whether or not all the queues that are defined in the queue definition files are actually used by the project, and vice versa. So if we've got a queue which is being used within the code, but it's never been listed in our deployment script, again, we have a potential situation where the developers have been manually creating queue definitions. And then when we go to use this particular piece of logic in a production environment, that the code breaks because the queue was never put into production, because it was never part of the deployment process. So we'll go through a few more. So for example, here we're looking at backlog 1 flow timer. So if we go back into our toolkit and look at backflow 1 flow timer, what we can see is we've got some input nodes that don't have exception handlers. So you may have an architecture decision where every flow has an exception handler, or you may have an architecture decision that no flow should have exception handlers, or handle failures. So again, it depends on how you want to look at how you want to configure the profile, and I'll show you in a second how the profiles are configured in Sonar. But basically, this is just saying that the standard for this organization is that there should be exception handlers on all the inputs to get a consistent chance to retry messages, or consistent logging, or whatever they decide to put in the exception handler. And in this case, this doesn't exist, so this would go, errors here would go straight to the backout queue, or the retry. We'll go through the retry to the backout queue if there's a failure in the logic. So I did mention that there's a thing called profile. So within Sonar, there's a thing called a profile which lists all our rules. So in this case here, we've got something called a default profile, which is our 166 rules. And then within the profile, and this can be only be changed by an administrator. So once the administrator has put it in place, this is the quality profile that people have to code to, and it will change over time. So for example, here we're just looking at the throws. Sorry, that's another exception. So I just need to find the message. Okay, input node has no cat channel. Input node has no throw handle. So these kind of go together, but you may have a particular architecture where you decide that might be separated. So in this case here, they come turned on by default, and so what you can do is decide to deactivate them, or in this case here, you can choose to deactivate them. You can choose to add some more comments, and you can choose to change the priority. So we might decide that this is a critical, or we might decide that it's a trivial and a minor, with the intention that the higher the criticalness of the issue, the more likely that someone is going to go in and look at it. So that's quality profiles. So that's a configuration that you can do from an administrative perspective to decide what's important in your code and what's not important. So we'll just go through a few more, and then we'll look at the diagramming component. So for example, here we've got a performance one, and this is a fairly new one, but what we're saying is that if you're calling copy message headers and you're calling copy entire message, then really the copy entire message is actually making the copy message header work redundant. So the copy message header is doing the same work the copy entire message is doing anyway. So you can probably either rewrite this code or just comment out this copy message headers because it's not needed. It's just doing extra work you don't need. So that's the general. That's just a bit of a dive into some of the exceptions. Some of the coding violations, but as I said, there's about 166 of them, and some of them are related to different coding standards and architectures that may be more applicable to some organizations over others. So we've got about 10 minutes to go. So what we're going to look at is, so that's the Sonar plugin and how it helps you improve your code quality. So you run through your run the analysis of your code. It gives you the types of issues it finds, and then you can decide which ones are important. Develop your own baseline of ones that exist and you're not going to fix, which you can do by selecting an issue and marking them as not going to fix, or tagging it to say being fixed, or integrating with. I believe there's a potential to integrate this with other products such as Jira or TFS, so that you can create Jira tickets and TFS tickets off the back of this analysis to get developers to go and fix things, which allows you a quality loop. So that's the analysis and code quality component. The other one, the next bit we're going to talk about is something called the diagramming, which is an extension of using the analysis tool to help improve communication. This is using the information the analysis tool, the stake analysis tool, has developed to produce some more business contextually useful information. And this is basically turned on by or configured within the properties, where we have a Sonar flow diagram output path, and this just tells us where we're going to be generating our diagrams into. So once our analysis is run, the plugin will automatically write a whole bunch of files to that directory. So what we can see here, I've just got a local web server running, and this is our particular demonstration software one we've just ran, and it produces a whole bunch of files, so the main one being the generated page. So the generated page is a visual representation of the information and architecture information that the analysis has found. So in this case, this diagram here is a diagrammatic representation of how the flows interact with each other according to their queues. So we'll be hopefully improving the information this has by adding the ability for queues to see through to their underlying alias, or I should say the alias to see through to the underlying queue, adding topics and subscriptions, and also adding SOAP endpoints, SOAP inputs and SOAP outpoints to get a better idea. But at the moment, this is just how it's based on interflow communication using queues. So for example, here we can see this particular flow takes a message from DCQ, or consumes a message from DCQ, and then potentially writes the same message out to the DCQ, which could indicate an architectural issue, where if you've got something that's reading a message from itself and sending it back to itself, then that may not be actually adding any business value, and it may potentially cause performance issues. But there may be a valid reason for this. It might be something to do with retrying, or it might be some other decision. But it gives you an idea of, it identifies that that's what's happening logically. For some of the ones we can see here, for example, that this particular flow is consuming messages from a queue, and those messages are being produced by 2 additional flows. And this gives you an idea of where if you're looking at a particular queue has failed, or what the impacts of turning off a particular flow are, or how a particular flow it gets triggered. Then we can see this particular flow, and the logic from this flow is triggered by 2 upstream flows, flow 4 and flow 6. And just we'll have a quick look at some of these other ones. For example, this one here. There was a couple interesting ones. So in this case, we're looking at a log. So we're saying all these flows log to the same place. So there were some interesting ones. Let me have a quick look here. I'm just trying to find a couple more. Okay. Oh, and just on these diagrams, this little description here is what's taken from the combination of the notes and the description and the flow itself. So just re-pulling in the documentation that you provided. So that's the diagram component. The other component to the that's the diagram, and the other component to the diagramming generation is this table of hopefully useful information. So what this table is it's a summary of interesting things that's found about the project. So for example here, it's just a summary of all the flows that's found within the project. In the case of subflows included, if there are any, no, in this case there's not. In case of subflows included, it's a list of all the subflows that particular flows are actually interacting with. So if you want to do some backward analysis of or impact analysis of what changing flow would look like, you can potentially do it from here, because you can see that this particular subflow or this particular flow is used by, or this particular subflow is used by other flows. In the case here, we can look at all the different flow names in the comments and descriptions. So the flow names by themselves may not be useful, but then again, by being able to see all the flow names in the same place, we can see whether or not there's a developed naming standard, or if we have a naming standard, if we should be looking to enforce it better, or whether the flow names are intention revealing. The queue summary. So the queue summary is a list of all the queues and how they interact within, or what they interact within the flow, within the broker. So in this case, here's a couple of interesting columns. So we're saying there's a queue, and it's used by a particular flow. So QA in this case is used by. So QA is used by. So QA is used within. These subflows, or these interacts with these flows. So we can say that QA is consumed by like a message flow drawing A, and is written to by display calls. The alias is where we have an alias for the queue, just to help us understand the queue name, what the queue is actually doing, if it's also got an alias attached. And MB, DP, and SI are columns for. So MB is message broker, so used by message broker. DP indicates that the queue is actually consumed or written to by data power, and SI is indicating that the queue is consumed or written to by Sterling Integrator. So if you have Sterling Integrator and data power code in the same project as your message broker code, or you can extend your message broker checkout, or you check out your message broker to include your Sterling code, and the analysis can include your Sterling code, then this will give you some idea of what the interaction between your Sterling components, your data power components, and your message broker components are. The SQL summary is an extraction and translation of the SQL that's found in the ESQL files and the message flows and the other components. So, for example, where we find SQL in data power, where we find SQL in ESQL in an SQL file. So this allows us to help us improve our communication with our database admin people and database designers, so we can give them a summary, or they can at their own time of their own choosing have a look through what our broker code and our data power code is doing to their databases, to try and get some sort of review of the database scripts are actually being run by the broker ideally before they go to production, before they looked at purely from, say, performance or highest number of contention, or all the other sort of database tools that DBAs use to tune their databases and see what's performing well and what's performing not. So by allowing us to sit with our DBAs early on in the process, they can help give us feedback on our combination of our table and our query design to make sure that they're happy and they think whether or not there's anything they could write better, or we could write better for them. A couple of these other tabs fairly just similar information. So the properties that are promoted, the data sources that are used, Java methods and stored procedures that are used, input files that are read from, input files that brokers are writing to, URLs that particular flows will be consuming, depending on whether they're a SOAP input or a HTTP input, and then the requests that broker is making out to external systems and where they're actually calling out to, or the URL, the destination they're calling out to. The exceptions is just a summary of the exceptions within the code. Thrown exceptions, so it just gives you the ability to make sure you've got some sort of standard there. So if you do want to have a standard coding exception numbering system, or standardizing your description, it just helps you come up with a standard and see where you've differed from it. Okay, so data power input URLs, where data power is consuming, where it's found at data power. Workflow, where it's consuming a URL or consuming, listening to a connection, and then where data power is actually calling out to other components, either by SOAP or HTTP. Then the last one here, where from this table we'll have a quick look at, is the all common ESQL methods. So this here is where it's tried to identify which functions and procedures are not located in a filter node or a compute node, sort of indicating that it's something that's going to be used a bit more commonly. So it's trying to identify things that look like they're common pieces of code, and then gives them in a summary in this table format here, with the intention that when new developers come along, or someone needs to write a piece of functionality, if they they can have a quick look here, and they can see what sort of existing functions are there that they may be able to use that they're not aware of. So they can do so they can look at the common piece of code, which doesn't do much, that one there. But for example, test duplications has got some common piece of code. Then they may say that's something I can reuse, or it's something I can modify or tailor, or that there's no code doing, there's no common piece of functionality doing what I need to be done. So I can write my own. So we're just coming in end of time. So if just anyone does have any questions, I'll give everyone about a minute to ask them. Otherwise, I'll let you get on with your evening and bid you farewell. Hopefully, everyone either got something out of the presentation. It wasn't a waste of your time. So hopefully, either come to a better understanding of what tools are out there, such as Sonar, which can help our quality and help our coding, make our coding easier, whether you're using a message broker, or in the case of Sonar actually supports a whole number of and variety of languages. So, and the one for message broker that we have is just one of them. So there's if you're developing other languages, then such as C or Flex or PHP, then there's a plugin that may be useful for you to help you improve the quality of your code and improve your processes. So it doesn't look like there are any questions. So as I said, good evening to you. I hope you found this presentation informative. And if you do have any questions or follow-up, please feel free to email me at richard@bettercodingtools.com. But that would have been in your that would have been in the invite, or is available from our website, www.bettercodingtools.com. And again, thank you.